I started this with the question, what the hell? I'm still asking, what the hell? I think I smell a project. Oven. Temperature control. It's time to hack. An unfortunate reality with food dehydrators is that even if they worked as advertised, I'd still be up against the very upper limit of what they're designed to do. They're designed to dehydrate, not to cook. And if they get hotter than about 80 degrees centigrade, they start to cook the food. That obviously wouldn't work. This little gem will get up to 450 Fahrenheit or about 232 centigrade. That's probably enough. What it lacks is really good temperature control. So that's where this comes in. Closed loop PID temperature control, with its accompanying solid state relay, thermocouple, and I have thrown in some high temp silicone wire, just for good measure. Don't know how much of that I'll need. But before I get carried away, I think the thing I need to do is a quick reality check on this, to see if it really does what I hope it's going to do. One last word before I get started. What I'm about to do is stupid and dangerous. Do not try to do this. Do not try to modify an electric appliance. I do not advocate the practice. I do not encourage the practice. And I'm not going to show a lot of detail as to how I do it. Alright, so I'm going to set this thing to what I would guess is about 80 degrees centigrade. It doesn't really have a thermometer that has any marks in that temperature range, so we'll probably have to use a little trial and error. And I'll use the stay on setting. Oh, no. I love it. Okay. Set it for an hour. As before, a couple of test coupons. This time, however, they are matte black sprayed sheet metal, because we'll be using temperatures that are above the limit of what the other test coupons could handle, because they were made of leather. So, control, one inside, and now we wait. I might have to do something about that fan too. That could be kind of annoying. We're homing in on it. I think that's a good enough test. This thing is operating near the bottom of its operating temperature range. But it seems like it'll be okay. I'm going to go ahead with it. I'd like to do a little bit of exploratory surgery. It's not too late to abort mission. I haven't voided the warranty. I could send this thing back. The thing that I want to know most is how I can interface to or replace the existing temperature control. what we have here is fortunately about what I expected. It may be difficult to see. Up here at the top we've got a bimetallic thermostat and a couple of timers. We've got connections to the heating elements, power to a fan motor, and power to a, what do you call that? A little, it's not an LED, but a little indicator up at the top. So this is pretty simple, and what I need to do is bypass and remove the temperature control and the timer, but I'd like to salvage this front bezel if I can, and then I'll print a new panel to go over it. I'll make a rectangular cutout and print a cover to go over the other two holes. So what we've got here is we have the end terminals for 4 different heating elements. We've got a motor for a circulating fan. I specifically got a convection type to eliminate hot spots. I didn't want to be relying on radiant heat. In fact, I'd actually kind of like to downplay that. And for that reason, I think I'm going to disconnect these top 2 heating elements. Maybe. That's my current thinking. In the bottom there's a drip tray which will provide some direct shielding for radiated infrared from the bottom elements, but there isn't anything provided for the top. So I'm afraid of melting spools. That would be bad. So on the other end, we just have the electrical connection between the top elements and the bottom elements. So all the action is down here at this end. This thing. I want to get these controls out of it without mangling it, because I'd like to continue to use it as a bezel on the front. But these knobs just don't want to come out. Oh, there we go. Just needed a little more encouragement than what I was able to give them from the front. That sounded really creepy and pervy. Liberated front panel. And a mess. Well, no matter. As I was saying, I have this thing about as far apart as I want to get it at this point. I've put a few screws back in to keep it from flopping all over the place. And I've taped up some of these edges because they're just murderous. And I've printed a new bezel that fits like here. And mounts the temperature controller and a power switch. What I need to do from here is mark some cut lines and cut the original stainless bezel. Well, that was fun. Broke my favorite cutoff wheel. Got a couple holes in here now. Think they'll take that back under warranty? Probably not. Assembly of the new bezel is achieved thusly. New bezel. In case you forgot, what I'm doing is really stupid and dangerous. Don't do it. Do not modify electrical appliances ever. Not joking. Alright, high temp silicone wire. We've got the thermocouple temperature sensor. And as a last chance safety measure, we've got a single use fuse, a thermal fuse, that I'll rig up inside this thing. In case of a thermal runaway condition, it will blow and cut off power, and it's not a breaker, it's just a fuse. So when it blows, it's done and the unit is disconnected. I realized a couple things when taking this apart. The first is that it's totally uninsulated. There isn't any insulation in it. So it's really energy inefficient. But the other thing is, the leaked heat into this cavity in the end here is how it was sensing temperature. It was sensing temperature indirectly due to the leaked heat energy. So that presents me with two challenges. So one, I can't hang with the energy inefficiency. My inner geek just can't let that go. The other part of it is that leaked heat energy into this cavity on the end here is the enemy of the electronics that I just put in. So, I'm going to do something about it. Enter ceramic fiber insulation. I will blanket the outside of this, the back, as much as I can of the electronics cavity here, if you will, and as much as I can on the bottom to try to improve the energy efficiency and protect the electronics. I also have some nifty barbecue smoker gasket, some high temperature stuff with its own adhesive that I can put around the door of this thing to reduce the drafts a little bit. I don't want to make it totally airtight. It needs to be able to breathe a little bit in order to evaporate the moisture out of the filament. But this thing's super drafty. It has holes all over the place. I want to plug some of that up. I have it all together now. It's ready for a final test to make sure I didn't break anything when I was doing the final assembly. Set point is 90 degrees centigrade. We'll let it do its thing and come back in a while. This thing's been cruising for a while now. It's had plenty of soak time. And I took the opportunity to rerun the PID auto tune and reset the offset. So it ought to be really close this time. And for a set point of 90, we get 90.9. Pretty good. It's been an interesting project. It started out with an investigation of my print dry, trying to figure out what the hell. It turns out that that thing's just a piece of junk and it doesn't do what it says. Moved on to a bigger, more elaborate food dehydrator, and that one didn't do any better. So eventually upped the ante a little bit, moved on to this thing, a little toaster oven, since they're designed to operate at a much higher temperature range. Fitted it with an industrial temperature controller, and it seems to do a lot better. It's pretty humble, still kind of looks like a sheep that's overdue for a shear, especially in the back, but I think it's going to do the job, and I'm eager to put it to the test. Thanks for watching. It's been a pleasure.